How do I find the diameter if they tell me the circumference? Well, remember, circumference is equal to pi times d. Do we understand that those are the same thing? Because 2 times the radius is the diameter. So if I've got the circumference as 12.5, how am I going to find the diameter? Y'all awake? Gotta wake up. How do I get the d by itself? Divide by what? Pi. Okay, 12.5 divided by pi is going to give me diameter is equal to 3.98. Okay, you with me?
So what'd you do?
I just solved for the d.
And so you
How do I
divide.
get that d by itself? I divide by the what's keeping it from being by itself. So I divide by the pi.
Okay.
Okay? Okay, simple algebra. That's all that is. What if they tell me that the circumference is 136.9 meters? And I want to know what the radius is and what the diameter is. How am I going to do that?
The same way you did the last one?
Same way I did the last
And
one.
then cut the diameter in half?
Okay? So then I'm going, I have 136.9 is equal to pi times d. So I'm going to divide both sides by pi to get my diameter. So 136.9 divided by pi is going to give me a diameter of approximately 43.6 meters. Okay, so that's right here. 43.6 meters. How do I find the radius?
You do that times 1/2.
Okay, I divide it by 2. So this is going to be a 21.7, actually it rounds to 21.8 meters. Okay, just make sure you know how everything's connected. That the diameter is twice the radius, and that formula or that formula can be used to get the circumference. Okay, that stuff is stuff that hopefully you've been working on a long time. This should not be the first time you have seen this. It better not be the first time you've seen this. Okay, any problems on that? I mean, do we understand it? We don't need to do one, right? All right. Now, we want to bring in some of the other stuff that we've done into this, of course. What if I have a circle? Oh, this is really going to challenge you. Okay? With a triangle inside the circle.
Crazy circle.
Okay, so I have a circle with a triangle there. The circle is circle K. And this right here is 3 on the square root of 2. And I want to know the circumference of this circle. Any idea how?
You said 3 on the square root of 2 is for what?
Okay, 3 on the square root of 2 is what this hypotenuse is equal to. Any idea?
Those should be equal to the same.
How do you know they're equal to the same? I agree, they are. I agree. So how do you know that, Rebecca?
The radius.
They're both the radius of the circle. Okay, so they have to, the distance from the center to a point on the outside is the same all the way around the circle. So these two things have to be equal, don't they? Now how am I going to figure out what they're equal to?
You can put right.
Do I?
Right.
How do I do that?
2x plus 3 on the square root of 2 equals 180.
Pythagorean theorem.
Oh, okay.
Okay, or you can do special case triangles.
You know that it's a.
Okay, you know that they're going to have the same measurement, okay?
You know that it's a right angle. Would they give you something?
You do know that it's a right angle,
Okay.
okay? X squared plus x squared is equal to 3 on the square root of 2 squared. You can do Pythagorean theorem on that, or you could do special case triangles, because these would both have to be 45s. Okay, now whether you remembered that or not, which I told you when we did it, y'all wouldn't remember it long. Okay, you could also do trig on it if you realize that those were 45-degree angles. But let's do Pythagorean theorem, let's stick to that. Okay, so I've got an x squared and an x squared, so I have 2x squared is equal to, when I square that, I have 9 times 2, which is 18, because 3 squared is 9, the square root of 2 squared is 2, so 9 times 2 is 18. I'm going to divide by my 2, and I'm going to get a 9. What is x going to equal? 3. Now, technically, the square root of 9 is plus or minus 3, but that's a distance, guys. There's no way my radius can be negative 3. Okay, so it has to be a positive 3. So now I know what the radius of the circle is. So now I can find my circumference. So 2 times pi times my radius is 3. So it's 6 times pi, which technically you could leave it like that, or you could go 6 times the pi button. It's going to be 18.8. Okay, units, because I have no, it didn't tell me centimeters, meters, whatever. Okay? Yes, no, maybe? Y'all with me?
Yeah.
Okay. All right, I'm going to do one for you to do. Okay? I'm going to give you a drawing up here, and I want you to find the circumference of this circle. Pretend that's a circle. That's supposed to be a straight line. Wow, I'm struggling drawing it. Okay. This is a straight line through the center of the circle right there. This is circle P, and I want to know what the circumference of the circle is. Yeah.
40.8.
Rachel.
I got 81.7.
Oops. See what Allie got. What'd you get, Allie?
40.8.
40.8. Okay, Rachel, let's see what you did.
I did 2 times pi times 13.
Okay, the 13, okay, that's what happened. The 13 is your diameter. So if you're gonna, and you can use the 13, but then you just go directly 13 times pi.
Okay.
Okay, if you're gonna use the 13 and you wanna use the 2 times pi times r, you gotta cut it in half. Okay, which I don't know, if you know the diameter, I don't know why you would wanna cut it in half, that's just one extra step. Okay, that's section 10.1. Now we're gonna go on to 10.2. We're going to talk about these angles in this circle. Let's say this is circle A, and it's got angle 1, angle 2, angle 3, and angle 4. What do I get when I add the measurement of those 4 angles together? How many degrees is that? How many degrees is it if I turn it all the way around? 360, because think about this person that's standing in the center of the circle. They're facing there, and they turn like that, then they turn like this, then they turn like this, and then they're right back to where they were. So anytime you have a circle and you add all, these are called central angles. The reason why they're called central angles is because their vertex is on the center of the circle. Okay, there will be a difference between inscribed angles and central angles. Okay, central angles means the vertex is at the center of the circle. Okay, so each of these things, if I add them together, they're going to always come up to 360 degrees. So I should be able to take a circle that gives me like some x values in it and figure out what x is equal to. So like for instance, let's say I have this nice little squatty circle. So that's the center of the circle. And I've got that. Now it doesn't really matter what these letters are, I don't guess.
I mean, it's getting better. This one's very like flat. It's very flat.
That was pretty good. Alright, I want you to try this. Tell me what x is equal to. Based on what you know already. That's good blank circles, I love that. It just makes sense. I guess because like that last chapter, the chapter 4 last, you had rectangles and rhombus and they all had something different versus a circle's a circle. What's your value for x?
12.
What's your value for x?
6.
What's your value for x? I don't know what you did.
I added them all together and then I divided.
Okay, well, for one thing, if all the way around the circle is 360, what's halfway around the circle?
180.
180, and that would be halfway around the circle.
So
You could do it that way, or you could go, well, these are vertical angles, so this would be 25x. These are vertical angles, so this would be, like if I put a line here, this would be a 2x and this would be a 3x. Okay, you could do it that way too, and then add them all up to 360. Or you could just go, you know what, that is through the center of the circle, so 25x plus 3x plus 2x equals 180 degrees. Okay, that would be another way to do it. So this is going to be 5x, so now I'm at 30x is equal to 180. And 30 into 180 is going to give me a value of 6.
Okay.
Okay? Now, the other thing that I know is I have arc measurements, if you will. And this is kind of a cool thing because, well, I guess we need to talk about arcs first. Let me erase some of that stuff up there.
Because every time you erase, does it unfocus?
No. And once it starts, it stays focused. Okay, let's say I just wanted to find this arc, AD. I'm going to write it like this. And I'm going to put a little
Rainbow.
angle thing over top of it, like a part of a circle, okay? Now, how do I know, because what I'm meaning by that is this arc right here. I'm meaning that measure from there to there. That is called a minor arc because it's less than 180 degrees. How do I know that I'm not talking about that arc?
Because you always go counterclockwise.
Mm-hmm. If I wanted to mean the other arc, which is a major arc, which is more than 180 degrees, I'm going to use 3 letters. A, C, D is going to be this arc right here.
It'll
Okay?
include every letter it passes.
No, it's just 3 letters. Okay? A major arc is named by 3 letters versus a minor arc is named by 2 letters. Okay, you're never gonna name an arc by 1 letter. Okay, so like what if I said, oh, arc C? Where's that going? Okay, I'm just gonna hang out right there and my answer is 0. Okay, so it always has to have at least 2 letters. If it's 2 letters, it's gonna be a minor arc, less than 180. If it's 3 letters, it's gonna be a major, more than 180. Okay, does that make sense? If I have a semicircle, I'm going to name it by 3 letters, but it's really not going to matter. Let's say that I have a letter directly across from this, and you go, well, how do I know whether it's just A-E or A-C-E? If it's exactly 180, how do I know? Well, does it really matter? Okay, if this is 180, what is that? 180. Okay, so both of those are going to equal 180. Okay, because, and here's the cool thing. Remember talking about central angles? This right here, let's say this is 120 and this is 60 right here. The arc measurement is the same as the central angle. So the measurement of arc AC
It's 120.
is 120. ACE is going to be 60. And then ACE, which is down here, is going to be 180. Okay? Does that make sense? Now, that only works with central angles. The vertex has to be on the center of the circle for that to work. If it's not at the center, and this is going to get confusing as we go on, because you're going to have some that are and some that aren't. It has to be at the center of the circle for there to be an intercepted angle. All right, I'm going to give you one of these to try. It's probably a good thing, but this stuff's relatively easy. I'm looking at your faces. It's probably a good thing it's easy, because y'all are just not awake. And it's not even raining outside.
It's very gloomy.
It is gloomy.
I've been up since 7 o'clock this morning.
Well, then you should be wide awake.
You would think so.
You would.
I've been getting up early, like every day for the past couple weeks. I have so much stuff to do. Day never stops, man.
Oh, wait a minute. I don't be happy with 3 videos.